All right, welcome to Chapter 5, which is titled, Does This Make Sense? Which is a prelude to it being no, it's not going to make sense. We're still in Chapter 16 in the book, okay, you know, that one that's collecting cobwebs. But it is Chapter 5 in your acid-based notebook that you will be compiling, okay? So the question is what is the pH of a 1.0 times 10, and then I'm sorry that it doesn't come up, but this is to the negative 10 molar HCl solution, okay? 1.0 times 10 to the negative 10. That should be an exponent right here. Good? Okay. Identify the major species of HCl. Now, remember, just HCl is not good enough. You need to know what HCl is, which luckily you all know is a strong acid. Okay, so what we have inside this container is a strong acid solution, some sort of aqueous hydrochloric acid solution. Okay, so write out the reaction. Well, it's not really a reaction, it's just HCl. Strong acid means one-way arrow, breaking apart into H plus ions completely and Cl minus ions completely. Okay, so like in Chapter 4, we did a strong acid, right? Really, it is none of this and 100% ionized. So 1.0 times 10 to the negative 10 molar H plus, and then Cl minus is also 1.0 times 10 to the negative 10 molar, again for the Cl minus, because they're in a 1-to-1 ratio. It's as simple as that for finding hydrogen ion concentration for a strong acid or a strong base, except these would be hydroxide ions. Okay, write out the equilibrium expression. Well, no, I'm not going to, because this isn't equilibrium. This is a strong substance. I have the H plus concentration off the bat because this is a strong acid. And look, I didn't even make you dilute anything. Boom, there's your hydrogen ion concentration. Solve for the pH. Remember, pH equals opposite the log of H plus. Now remember, I told you when this is a perfect one, whatever your exponent is, that is your whatever value, in this case pH value. So this exponent is a 10, so my pH is 10. Now sig figs wise, 10.00. This is 2 sig figs because this was 2 sig figs. Remember, decimal sig figs don't start till after the decimal place in pHs and POHs. Okay, so we've got a pH to be 10. And then you go, what? That is an acid. And obviously we're assuming the temperature is 25 degrees Celsius. So this pH is a basic pH, and we have hydrochloric acid in there. So no, this does not make sense. Here is the deal. The concentration of the hydrogen ion is so small coming from HCl. It's only 1 times 10 to the negative 10. So that's 0.000 with 9 zeros and a 1 of hydrogen ion in there. So here is what you have to remember. That the main source of hydrogen ion in here is not going to be coming from the acid. Who is the other substance that will contribute its hydrogen ion? Well, this is an aqueous solution, so it is water. And water's hydrogen ion concentration is 1.0 times 10 to the negative 7th molar, right? Remember, 1 times 10 to the negative 7th times 1 times 10 to the negative 7th is 1 times 10 to the negative 14th. Remember, H plus OH minus equals KW. So the main contributor of hydrogen ion in this solution is not from HCl. This is a much greater concentration of hydrogen ion, just from the fact that there's water present because it's aqueous, than 1 times 10 to the negative 10. So what is the pH then? Well, because the hydrogen ion concentration is that of water, that's the main contributor. You are ending up with opposite the log of 1 times 10 to the negative 7. So the pH is actually neutral. you have such little acid in there that the only contributor you're getting is that from water. So you have a neutral pH. Okay? This same thing would be true if they did this for a base and you ended up with an acidic pH. Bases cannot be acidic. So if it comes out acidic, the main hydroxide contributor is going to come from water, not from the actual tiny base concentration. And so your pH ends up coming out to be neutral, that of water, who your main contributor is. Okay.